Concentrating solar power is an emerging new technology that provides clean, renewable energy. If you look at the photo here on the left, you'll see thousands of mirrors called heliostats reflect sunlight to the top of a tower where a receiver collects that light. Molten salt is pumped through that receiver and it's heated up to over 500 degrees Celsius and stored in a storage tank. Now anytime, day or night, that molten salt can be used to dispatch energy by using that molten salt to create steam from water to drive a turbine and a generator. My name is Jesse Wales. My research is to create a maintenance simulation model that simulates failures and maintenance events for the critical components of a concentrated solar power plant. Some of those critical components are turbines and generators, heat exchangers, and certain valves and pumps. My literature review has shown that each of these critical components has different types of failure modes, such as failing to start or failing to run within the first hour or after the second hour. We've built a C++ model to simulate when these components fail using different beta and gamma distributions for those components. If you look at the bottom right, you'll see in yellow here, these are some models that have previously been built. This dispatch optimization model, it maximizes profit by selling electricity to the grid. So it tells the system when it should create that electricity. It has inputs such as weather and electricity pricing throughout the day. The output is a schedule for 48 hours of when the system should be online or offline and generating electricity. The downfall to that model, or what it's missing, is the impact on the critical components. So it could be maximizing how much profit is made without any regard to the wear and tear of the critical components. That's where the simulation maintenance model comes in. It takes that schedule and applies it to the critical components. So if the components are potentially being abused, such as too much cycling or ramping energy up and down too quickly, then that's going to have an effect on the overall costs of maintenance, and so your profits are going to go down. So this model is integrated and run in a 48-hour loop cycle over an entire year. Now the goal of this research is to quantify the impact of these optimized schedules on maintenance. What are the costs of maintenance? How much does it take to repair? And what is the impact on overall profit for the system?